Okay, students, moving with the next question. Question number 23. In the chemical reaction, K2Cr2O7 plus AH2SO4. Let me write the reaction. K2Cr2O7 plus AH2SO4 plus AH2SO4 plus, it is given that BSO4, but it is actually BSO2. Okay, it is an error. BSO2, which forms K2SO4 plus Cr2SO4 thrice plus CH2O. So there are three general coefficients A, B, C, and you are asked to find the values of A, B, C. Okay, so let's balance this one. Ready? So it is clear that here we have a chromium plus 6. Chromium is in plus 6, and here the chromium which is in plus 3, and here 2 chromium, here also 2 chromium. So the numbers of chromiums are same. And the sulfur which is in plus 4, right? Yes. And what about here? It is in plus 6. Ready? Okay. So what is the number of electron gained? Electron gained is change in oxidation state plus 6 to plus 3, that is 3. And number of electrons, that is 2. So electron gained is 6. Electron gained is 6. Okay. Like, what is the number of electron lost? Electron lost, that is the change in oxidation state is 2. Simply 2. From plus 4 to plus 6, the change is 2. So here gained 6, lost 2. So here you have to multiply with 3, right? Yes. So here is a 3. So 3 sulfur is here, and exactly the 3 sulfur is in this molecule. Okay. So it is balanced now. Ready? Then what about the, so electron gained and lost are balanced. If here is a 3. What about the potassium? 2 potassium, 2 potassium. So 3 sulfur here, that 3 sulfur is balanced here with the lost gained. And what about the rest of sulfur? Here is a SO4, exactly same SO4 here also. So we require 1 SO4 because already the 3 sulfur balanced here. Ready? So only one H2SO4 is enough. 1 H2SO4 means 2 hydrogen is there. So here it should be a 2. Potassium is already okay. What about the oxygen? 7 and 4 and 6. 7 plus 4 plus 6, 13, 17. What about here? 4, 12, 1, 17. Perfect. So this will be the coefficient. So A is 1, B is 3, and C will be 2. Okay. So your choice is 1, 3, 2. 1, 3, 2 will be the choice. Okay. 1, 3, 2 will be the choice. 1, 3, 2. I'm sorry. This is not 2. This is 1, right? 1 hydrogen is there. So this is 1. I'm sorry. C is 1. It is a mistake. C is 1. So fine. 1, 3, 1. That is the choice. Okay. Can choose the choice as 1. Option number 1. Okay. Moving to the next question. Question number 24. Question is oxidation number of sodium in sodium amalgam. Oxidation number of sodium in sodium amalgam. It is already discussed in the theory part. In metal amalgams and metal carbonyls, the oxidation state of metal will be 0. Okay. So the oxidation state of metal will be 0 in metal amalgam and metal carbonate. So the oxidation state of that sodium will be 0. The choice will be 2. Move to the question number 25. 25. What about the question number 25? Which of the following compound cannot oxidize ozone? Sorry. Which of the following compounds cannot be oxidized by ozone? So, which of the following compound cannot be oxidized by ozone? So here ozone is the oxidizing agent. Okay. And you are given with the 4 categories like potassium iodide, potassium permanganate, like potassium manganate, and ferrous sulfate. These all are the compounds. And the question is, among this category, which one is not oxidized by ozone? Not oxidized by ozone. Okay. Ozone is a good oxidizing agent. Ozone is a good oxidizing agent. So it can oxidize elements. So here iodine is in -1. So iodine can be oxidized to +7, from -7 to +7. So iodine is in a lower oxidation state. So it can be oxidized to its higher one. So ozone is able to oxidize iodine. So this is okay. What about potassium permanganate? It is in potassium permanganate, the manganese is already in the higher oxidation state, that is +7. And this is a powerful oxidizing agent. So your ozone is not able to oxidize permanganate since it is in the higher oxidation state. So this movement is not okay. What about K2MnO4 potassium manganate? It is in +6. So it may be oxidized to +7. And that oxidation may carried in presence of ozone. So ozone can oxidize K2MnO4. Like this is ferrous sulfate, and you know ferrous ion may oxidize to ferric, and this oxidation can bring by your ozone. Okay. So the only one which is not attacked or which is not oxidized by ozone is the topmost oxidizing agent, your potassium permanganate. So this is the choice. Okay. Moving to the next question. In alkaline medium, KMnO4. In alkaline medium, KMnO4 react as follows. Okay. Then what is the equivalent weight of KMnO4? That is the question. Equivalent weight of KMnO4. Okay. Equivalent weight will be equivalent weight of KMnO4 is the question. So the KMnO4 in alkaline medium, you know, in strong alkaline medium, KMnO4 may oxidize to, KMnO4 reduced to K2MnO4. So let me write the question 26, and we know about the nature of product. 2KMnO4, it is in a strong alkaline medium, that is 2KOH. Okay, and it turns to 2K2MnO4. And this reaction is in a balanced stoichiometry, plus H2O, plus O, whatever it may be. Anyway, in strong alkaline medium, potassium permanganate from +7 reduced to +6. And you know that equivalent mass is nothing but it is the ratio of molar mass to the n factor. What is the molar mass of KMnO4? The mass of KMnO4, that is 158, approximately 158. And what about the n factor? The change in oxidation state for 1 molar. The change in oxidation state per mole is the oxidation state here. Per mole means there is only, this is a stoichiometric coefficient. Per mole means you simply take 1 KMnO4 and simply check the change in oxidation state. Okay, so the change in oxidation state is +7 to +6, only 1. Okay, so the n factor is 1. So the molar mass and equivalent mass is very same, that is 158. Actually, it is 158.36. Okay, simply you choose 158. And the option is D. Moving to the fourth, D means the option fourth one. Okay. Moving to the next question. the equivalent mass of FeS2, equivalent mass of FeS2 in, I think you seen the question, the equivalent mass of FeS2 in. Okay, so there is a reaction like your previous question. FeS2 plus O2 gives Fe3 plus SO2. Fine. Whatever it may be, in FeS2, the sulfur which is in a -1 oxidation state. Ready? And now it turns to +4. +4. Okay. So what is the change? The change is 5. Ready? The change is 5. For sulfur, what about iron? It is from +2 to +3. The iron is changed its oxidation state from +2 to +3. So what is the change? Change is 1. Okay. Then what about the equivalent mass? Of your FeS2. Fine. Listen here. Equivalent mass is molar mass divided by n factor. What is n factor of FeS2? The total change per mole. Total change per mole. What is the change of Fe? Fe having a change of 1 from +2 to +3, and number of Fe 1. Sulfur having a change -1 to +4, that is a change of 5, and number of sulfur is 2, so the total change is 11. So the equivalent mass will be its molar mass divided by 11. Is it okay? Fine. Moving to the next question. Question number 28. That is, when SO2 is passed through acidified dichromate, the oxidation number of sulfur changed from. So when dichromate is reacted with the SO2, the dichromate is a powerful oxidizing agent and it can oxidize the SO2 to SO4 2-. Okay. So the oxidation state changes from +4 to +6. You know, +4 to +6. So +4 to +6. Ready? All the rest of choice are reduction. This is a strong oxidizing agent, so it should oxidize. There is only one choice, that is +4 to the oxidation, the choice which represents the oxidation of SO2. There is only one here, and in that sense also you can choose the choice as third one. Moving to the next question. Question number 29. What about the question? How many mole of FeSO4 reacted with 1 mole of KMnO4 in acidic medium? How many mole of FeSO4 reacted with 1 mole of KMnO4 in acidic medium? Okay. How many mole of FeSO4? So you are given with the FeSO4. FeSO4 in FeSO4, the only part which undergoes oxidation is Fe2+, because SO4 in the rest part is SO4 2-, right? SO4 2- is already in the maximum oxidation form, in the maximum oxidation state, +6. So it won't oxidize, okay? So the components you simply choose as Fe2+ in FeSO4, okay, for the basic skeleton, and with the 1 mole of KMnO4. So you know MnO4-, and this is in acidic medium. This is the question. And you know that in acidic medium, MnO4- become Mn2+, and in presence of that oxidizing agent, your Fe2+ may oxidize to Fe3+. Okay. So what about the change? Change here is 1 into 1, that is 1. Change here is from +7 to +2. You know, it is already discussed in the theory. The change is 5. So here is simply multiply the 5. This is enough for our question. What is our question? Our question is, how many mole of FeSO4, which means this one, is reacted with 1 mole of KMnO4. So it is clear that 1 mole, here is 1 mole MnO4 minus require, 1 mole MnO4 minus require 5 mole Fe2 plus. 1 mole of MnO4 minus require 5 mole Fe2 plus. So it is perfect. Ready. The next 30th question. Listen here. 30th question. What about the question? Just read it. A compound of xenon and fluorine is found to have 53.3% xenon and it is only given, and the atomic mass of xenon is 133. Oxidation number of xenon in this compound. So a compound of xenon, okay, 53.3%. So here the percentage composition of that element is given, right? Okay. So a compound with the xenon and fluorine, right? Yes. And the percentage composition is given as 53.3%. So what will be the percentage composition of fluorine? Total is 100. So this one will be 46.7%, right? Yeah. And the atomic mass. The next term is atomic mass. I think it is familiar in your some basic concept in chemistry, or the calculation of empirical formula. Okay. So let's move on with empirical formula. Ready? And if you obtain a empirical formula like this, XeFN, we know that the charge of fluorine will be -1 into the number of fluorine is N. So the total charge of fluorine is -N. So the charge should offered by xenon part will be +N. So you have to know the ratio between xenon and fluorine. That is the only idea for this question. For the ratio, if you are given the percentage composition, you can simply divide the percentage composition by atomic mass, so that you obtain the empirical formula, right? Yes. So the percentage composition is given in the question. Atomic mass of xenon, it is not familiar for us, so it is also given in the question. That is 133. But the atomic mass of fluorine, that you have to know, that is 19. Fluorine F919. Okay. So the next step is finding relative mole. Relative mole. I think you are familiar with these steps, okay, in basic concept. 53.3 divided by 133. 46.7 divided by 19. Okay. And so what about the case? If it is 533, 133, 266, 266, 266. What will be the answer? 2, 1, 3, 1, 5, 532. Fine. So this will be 4 times. So this will be 0.4. Is it correct? Yeah. What about here? 46.7 divided by 9. 2 times will be 38. So the rest for 46, 38, 39, 30, 40, 46, 8 will be the remaining. 8.7 will be the remaining. Divided by 9. If it is 8.5, sorry, if it is 9.5, then it will be 0.5. So this will be a 0.4. So a 2.4, I think. 2.4. Okay. So convert this into simple whole number ratio. Simple whole number ratio. How can we convert this into simple whole number ratio? By dividing with the smallest among this category. 0.4 divided by 0.4. The smaller among these two is 0.4. So this one will be 1, and 2.4 divided by 0.4. This one will be 6. So this is a simplest ratio between the elements xenon and fluorine. So the ratio between xenon and fluorine is, tell me, 1:6. So the molecular formula will be XeF6. If the molecular formula is XeF6, then this will offer -1 into 6 plus -6. So your xenon, I'm sorry, -6. So your xenon should offer +6. So the oxidation state of xenon will be +6, right? The oxidation state of xenon will be +6, I think. Okay, it's a good question and something which is related with your some basic concept in chemistry also. Okay, so moving with the next question. That is moving to your next question. That is, which of the following is not correct for electrochemical cell? And I already told you that our next chapter is electrochemistry. So this kind of questions will be discussed in your electrochemistry. Okay. So post it though. Okay. 31 question number 31st. Simply post it though. We will discuss it in, after your electrochemistry. Okay. So moving to the next. 32. Which of the following is not a redox reaction? The choice A is H2 plus Cl2 gives 2HCl. It is a perfectly good redox reaction. The next choice, that is NaOH plus HCl gives NaCl plus H2O. The reaction between a salt and acid and base is not a redox reaction. So you can choose the choice as 2. 2 is a reaction between acid and base. It is not a redox reaction, no doubts. Photosynthesis and photosynthesis is a perfectly oxidation reaction. So it is a redox reaction, no doubt. And in cell respiration, I think there are number of electrons are involved. Yes, so it is oxidation reduction reaction. Question number 33. Redox reaction have no concern with the, which means which of the following is not a redox reaction? First one, neutralization of acid and base. No doubt, it is not a redox reaction. Second one, salt hydrolysis. Salt hydrolysis is, let we have NaCl and it is hydrolyzed. How would it get hydrolyzed? Here OH, here H. So will be NaOH plus HCl. So salt hydrolysis is nothing but it is a reverse neutralization. Reverse neutralization. This is from here to here neutralization, here to the reverse neutralization. So neutralization is not a redox reaction. So reverse neutralization is not also a redox reaction. The third one is esterification. What do you mean by esterification? You have a carboxylic acid here, ready, and alcohol here, and which condensed like this to form a ester. Ready? So there is no change in oxidation state, right? Yeah, there is no change in oxidation state. So this is not also a redox reaction. This is some kind of dehydration. It's not a redox reaction. Okay. So all of this have no concern with the redox reaction. Your choice is 4. Question number 34. Listen, question number 34. You are given with the reduction of nitrobenzene in weak acidic medium. It is a electrolytic reduction to form aniline. And what you are asked to find? The N factor in this process. N factor means number of electrons involved for 1 mole. Okay, and the stoichiometry of this reaction is like this. The reduction of nitrobenzene will be discussed in your amines. Okay, RNO2 plus 6H plus 6 electron gives RNH2 plus 2H2. This is the actual general reduction of your nitroalkane to aniline. So like here will be a 6H plus 6 electron. So then for 1 mole, and this is for 1 electron. So for 1 mole nitrobenzene, it required 6 mole electron. So the n factor is not out. What is the n factor? It is 6. N factor will be 6. Ready. Moving to the next question. In the process of photosynthesis, which takes place in green plants, which undergoes reduction? Which takes place in green plants and which undergoes reduction? For photosynthesis, in the case of photosynthesis, which species undergoes reduction? And you know the photosynthesis reaction, 6CO2 plus 6H2 plus O2, gives C6H12O6 plus 6O2. I think this is a reaction in photosynthesis. Yeah. Fine. So, which undergoes reduction? Which one undergoes reduction? Which one undergoes reduction means I think carbon dioxide undergoes reduction because here it is in +4 and here it will be 0. Okay. So carbon undergoes reduction, which means carbon dioxide undergoes reduction. So the choice is 2. Okay. So your next is section B.